So Peter and John had $510 altogether. Peter gave 40% of his money to his father, and John spent 75% of his money. They then had an equal amount of money left. How much money did Peter give to his father? All right, so for this question, as we can see, we are given the total money from the beginning. This is your before. Now, and they have changes provided here. So the changes is that Peter gave 40%. So this is an external transfer. I hope you can tell that because this is what he gave away to his father. And his father is not in the calculations or whatsoever in this question. Same for John. John spent away 75% of his money. So these two changes, these two percentage changes are external transfers. All right. Now, and finally, in the end, they had an equal amount of money left. Okay, so looking at this question, there's a lot of things. You have percentage changes and you have equal left in the end. Now, all these things, percentage and this equal left, we can later write them as a ratio. All right, so if you notice, we have all this information, percentage and equal, all this can be translated to a ratio. Why I say we use ratio to solve is because you can easily apply your common base. Okay, so once you have mastered your common base, you can actually apply them to such questions. Although it doesn't seem like a ratio question, it seems more like a percentage question. However, applying ratio concept will be more valuable in this case. Okay, it's easier for you to apply later on. So we shall see how to apply that. So for now, what I can do is I'm going to record down before, change, and after. No point using model for this because they gave us total value at the beginning. There is no sort of comparison as to saying who has more, who has less in the beginning. Okay, so model in this case, no, we wouldn't apply that. We will apply before, change, after. So in the before information, I have 510 all together. So we can just simply put P plus J. All right, if you put total equal 510 also can. Now then the change comes whereby I draw an arrow to indicate a change. So Peter gave 40% of his money to his father. All right, so 40%, before I change that to a ratio, let's simplify that to a simplest fraction first. Okay, so I change to a fraction, then I change to a ratio. So 40% means 40 over 100, which simplifies to 2/5. So Peter give away, so it's a minus 2/5. Now, and from here, I can write this down because this is a proportion change. Okay, a proportion change meaning to say that a change that involves like a fraction, a change that involves a percentage, all these are called proportion change. All right, so I'm going to rewrite this as what we call a BCA ratio. BCA meaning before, change, and after. So it's like a mini BCA ratio. So yes, when we record down the data, we have like a big before, change, and the after at the back. But within the fraction, within these changes itself, I can rewrite them as like a mini BCA ratio. Okay, so what is the B here? Now the B here means you're going to use the total of 5 units that Peter had initially. That will be what he owns before he gave away the money. So Peter owned a total of 5 units, that's the before. Now what's the change? The change, of course, will be the numerator. Out of 5 units, he gave away 2 units, so minus 2. Alright, and after means whatever is left. So from 5 units, he lost 2 units, which means now he's left with 3 units. So this is how we write our BCA ratio. I'm going to erase this because I will show that on the slide. All right, so there'll be 5. So minus 2 is to 3. If you would like to add in the title B to C to A, please go ahead. Now, and moving on to John. Okay, so for John, we're going to draw another arrow. No point squeezing it here. Draw another arrow to show the change for John. Same for 75%, simplified to a fraction, which will be 3/4. So John spends away 3/4. Now again, we're going to translate this to a BCA ratio below. All right. So when we say that he has spent 3/4 of his money, that means the 4 units that he had was the at first, the before. Okay, so there will be 4. There will be before. Now out of 4 units, he spent away 3 parts, so minus 3. That is the change. After that, whatever is left, just do the subtraction. 1 unit left. Okay, so 4 to minus 3 is to 1. That will be our B to C to A. Now, and finally, in the end, the after part here. After here is whatever they have equal amount left here. That's what the question says. So equal left, you can again put that down as a ratio. T to J ratio, 1 is to 1. Okay, so first step of recording our information done. Okay, we've finished recording our data. Now the next thing is to identify our common base because we see 3 sets of ratio here. 1, 2, 3. Now when you have 3 sets of ratio, typically you will expect 2 pairs of common base. Okay, when you have 2 sets of ratio, you will only expect 1 pair of common base. So when you have 3 sets of ratio, typically, generally, we expect 2 pairs. Okay, not all the time, but most of the time, yes, we expect 2 pairs of common base. All right, so let's figure out what's our 1 pair of common base that we can figure out. So as we can see, this ratio is the after ratio. Okay, this is the after. So we look at Peter ratio here and the last one first. Now notice that Peter's after ratio is the first pair of common base because this, I have Peter's after information, and within this ratio also I have Peter's after information. I have the change of the before, but I don't really have common base for those, right? Because there's no before ratio. Okay, next pair of common base, John and the last one. Okay, so usually compare this and this because this one got 2 of them, 2 people in the ratio. So Peter, John, John. So John and John, common base will be again the after part. So John's after is your second pair of common base. Okay, so we are going to proceed to make them the same. Let's start with Peter first. Doesn't matter if you start with John or Peter first, up to you. This is your choice. Okay, let's start with Peter first. So Peter's after here shows 3. Peter's after here shows 1. So I need to change this 1 to 3 as well. Make them the same. Okay, and we're going to do the same for John. All right, so we do the same for John. So we see John here shows after 1 unit. Now John, now it's 3 units. Okay, always look at the latest unit. So John now shows 3 units here. Here is 1. So I need to change this 1 to become 3 also. So everything times 3 together. Okay, and then check back for Peter. Was it affected? Peter was 3, 3. Okay, no change, not affected. All right, so finally we can underline and circle our common base. So underline and circle is just to differentiate the 2 pairs of common base. So PP, 1 pair, John, the other pair. All right, so now that we have identified both pairs of common base, we can proceed to start looking at the value that the question has given us, the value that we can use moving forward, which of course is the $510. All right, so to work out the $510, to start with the $510, you will need to find out how many units is representative of this 510. Okay, so we settle each point one by one first. So let's look at Peter first. Now what we know here is this is the before information. So to find Peter before, we gotta look at this ratio. So this ratio Peter before is the 5 units. Okay, so we're just going to transfer that down here and do the same for John. So John before, so look at John before this 12, not 4, okay? Use 12 because I've already established all our common bases. We've already common base unite these 3 families together. All right, so it doesn't make sense to use back the 4. All right, so John's before is 12, call that down here. And as we can see, a total of 17 units will be my 510. So you see that the steps that follows is quite straightforward. The only challenging part for such a question is identifying your common base and of course recording down the data in the correct manner. Okay, once you have overcome that, I can guarantee you that the steps that really comes after that is straightforward and you just need probably maximum 1 minute to solve the steps. All right, so don't worry if you're spending more time on identifying your common base, it's okay. The bulk of the time is spent on doing that first. All right, okay, moving on, let's find 1 unit. So 1 unit is 30. So once you have found 1 unit, reread the final question to see what is required. How much money did Peter give to his father? So Peter giving to his father. Let's look at Peter's ratio. Now, how many units did he give to his dad? Okay, so remember the giving is the change, this one, the minus 2, right, that he given away to his father. So you got to find 2 units, which is 30 times 2. Hence, he gave his father $60.